Hello there. Welcome to part 8 of the Wireless LAN Security Mega Primer. In this video, we will be looking at hacking WLAN authentication. So, what is WLAN authentication to begin with? Now, if you remember previous videos, we had seen that when a client and an access point connect, there are various steps. The first is a probe request and response, followed by an authentication phase. After that, we have an association phase, and then post that data transfer happens. So in this video, we will look at how to break the authentication phase. Now there are two kinds of authentication which can happen in a WLAN system. The first is open authentication and the other is shared authentication. So what is OpenAuth? Well, the funny thing is OpenAuth does not require you to give any credentials or any authentication stuff anyway. So actually, it is just a plain two-packet exchange where the client and AP just agree that, well, you know what, we are both authenticated. There are some corner cases like what we saw in the previous video, that if MAC filtering is enabled and the client is not in the whitelist, then open authentication will end up failing, as it happened in the last video, right? Apart from this, there is nothing much in open authentication. If you think about it, any client can actually authenticate using open authentication, regardless of whether it is an authorized client or not. Which brings us to the next kind of authentication, which is shared key authentication. Now, the prerequisite for shared key authentication is that web encryption has to be enabled. Now, web, for some of you may be a new word, or you may be aware but not very sure about how web encryption actually works. In this video, we will take certain things for granted, which we will cover in later videos when we talk about web and WPA cracking at a later stage. So here is the only thing I want you to understand about web, or I would not really say understand, but take for granted. Web encryption actually requires two things. The first is a 3-byte value called an initialization vector, which typically changes per packet. And the second is the web key itself. Now, the web encryption algorithm uses RC4, which is actually the real encryption algorithm, and passes the web key and the IV, or the initialization vector, to the RC4 algorithm, which creates a key stream. Now, this key stream is actually XORed with the actual plain text and put inside the packet and sent across, right? We'll revisit all of this later on when we talk about web in more detail, but keep this basic stuff in mind. Now, let's try and understand how shared key authentication actually works, right? Let me just switch on the fan in the room. It seems to be quite hot in here. The Indian summer has started. I have an air conditioning, but it makes a little bit of noise, so I typically switch it off during the videos. Anyway, so the first packet is actually the authentication request packet sent by the wireless client to the access point. Now, when the access point sees that packet, it says, okay, you want to authenticate, here is a challenge, solve it. Now that challenge is nothing but a 128-byte plain text. That's all there is to it. When the client receives this challenge, which is nothing but 128 bytes of plain text, and this plain text is something the access point is supposed to randomly create, right? This plain text is not known a priori. The client now uses the web encryption algorithm to encrypt this plain text by choosing some random initialization vector along with it, and then sends this encrypted plain text and the initialization vector back to the access point. The access point uses the initialization vector and the web key which it had, which is same as what the authorized client would also have, puts it into the RC4 algorithm, gets the key stream, XORs the key stream with the encrypted packet, and that gives back the original plain text packet, right? Now, you may kind of think, well, how did I get the plain text packet back? little bit of math here. A XOR B is basically, now if you go ahead and use A XOR B and then XOR it back with one of the entities, you actually get back the original one. Don't worry, we'll take that up in a separate slide. Now, depending on if the decryption succeeded and the access point got back the original plain text, it will send an authentication success or an authentication failure, right? So let's try and understand this a little bit more in detail. So we've talked about all of this. Challenge is encrypted using the web key. Web uses RC4, which is a stream cipher, and RC4 key stream is XORed with plain text challenge and response. Okay, we'll discuss web later, don't worry about it. Now, before we do this, let's quickly go ahead and do a demonstration. Now, what we really want to do is capture the whole authentication request response and the challenge and all of that, right? And what we also want is that once we have the challenge text and the plain text, we want to do a XOR, right? I'll tell you why in a minute. So for this, we're going to run arrowdump ng. Let's ensure actually that our access point is on channel 1. Indeed it is. Here is our access point. Let's go ahead and add another filter to just decrease the clutter a little bit on the screen for the BSSID. And what we will do is we'll actually tell it to write whatever it is finding over the air onto a file called demo, right? So now all of these packets are getting stored into the demo file. Now notice something interesting here in the output under auth, right? There can be only typically two values, open or shared key. Now here nothing is being mentioned. The reason is what arrowdump will actually do is when the first shared key authentication happens, at that time it will capture the whole authentication request response, the challenge text, etc., store it onto a file, and then mention the authentication mechanism here. So let me take my handy little access phone, iPhone, and now if you notice, Wi-Fi is turned off. Let me turn on Wi-Fi and let me connect to the security tube network. Now it's connected to my home access point, and I'm about to enter a web password here. I click on join, and if you notice, now it is connected to security tube, right? And if you notice, in the meantime, arrowdump has actually mentioned SKA here, right? Just to kind of signify that, well, shared key authentication is what is being used. Now, very quickly, one thing which I forgot to tell you guys is I have configured my access point already to use web. Security mode is web here, and I've set a web key, and the authentication has been set to shared authentication, right? So you will need to make appropriate changes so that your access point also uses web encryption. Okay. Now let's kill this and let's look at what arrowdump has stored currently in the local directory. Now demo.cap is actually the capture file where all the packets it has captured over the air has been stored. Now another interesting thing here is 140 bytes of key stream have also been captured, right? This is beautiful. And if you notice, this is having the same BSSID as our access point, which means the entire interaction of the challenge text being sent, the encrypted text being sent back, all of that has been captured. So let's actually open up Wireshark and look at it. right? So let me actually go into the security tube directory, wireless. This is where everything is running. And one of the other interesting things some of you may not know is we can directly give the capture file name to Wireshark. That way it just goes ahead and opens up the capture file directly. Now what we need to do is add a filter for wlan.addr equals, and this is where we place the MAC address of the access point. Hit an enter. This is what we get here, and what we are really interested in is just the authentication packet. So let me just apply a quick filter for AND authentication, right? Beautiful output, beautiful. 4 packets have gone back and forth. The first packet is actually originating, if you notice, from our Apple client, which is the iPhone, to the wireless access point. And basically what we need to track is the sequence number of the packet. So authentication sequence 1. So in this packet, the client is requesting the access point to begin the shared key authentication mechanism, to which the access point replies back with packet number 2. And actually, if you remember the slides, packet number 2 is the challenge packet, which is exactly what the client, the access point sends. So this is a challenge text. The size of the challenge text is 128 bytes, right? Now the client is supposed to encrypt this with the web key and also add a unique initialization vector, right, which it uses as part of the encryption. So let's look at what the iPhone did. Awesome. So if you notice, now we have a little different header which says web parameters, and here is the initialization vector, right, which is a 3-byte value, as you can see from the dump here. And this is actually the encrypted text or the challenge which was sent. Beautiful, beautiful, right? Now what happens is the access point goes ahead, decrypts the challenge, gets satisfied that yes, everything is absolutely correct, and that goes ahead and finally sends out the 4th packet, which is the success code. Awesome. So these 4 packets together is what constitutes the authentication request response for shared key authentication. 4 packets, if you notice here, sequence is 1, then we go to the next packet, the sequence number is 2, this is where the challenge is sent. Next packet, sequence is 3, well, it's not kind of mentioned here anywhere, but that is what it means. And finally, sequence is 4, right? Now you may be kind of going ahead and thinking about something interesting, is that the challenge was only 128, but now the encryption is happening over 136. Why is that? Where did those extra 8 bytes come from? So I leave that as an exercise to you. Things will be clear when we take web encryption up, okay? But what I want you to take away here is that challenge is sent, AP decrypts the challenge successfully, allows for authentication. Now let's go back into how we can break shared key authentication. So simple math, the attacker is just going to probe all of this exchange which is happening, and this is exactly what we were doing right now. We were probing the authentication request, response, and everything going back and forth between my iPhone and my access point. And what did we get? We got the plain text challenge, yes we did. We got the ciphertext response, yes we did. It's almost like yes we can. So X is the plain text challenge, let's assume. Y is the web key stream which was produced, and Z is the encrypted challenge. Now the encrypted challenge Z is nothing but XOR Y. This we will come about all of this in the chapter on web. Don't worry, just take it for granted right now. what we will do now is just a plain text XOR between the challenge and the encrypted challenge, and this will give us the key stream used to encrypt the packet. Now, if this is not very clear, don't worry. In the chapter on web, all of this will be taken care of, right? So, but here is the takeaway right now. Once we have the key stream, we can encrypt any challenge. So what this means is, with this key stream and the IV, now if we go to the access point and say, well, we want to authenticate, and the access point sends a challenge to us, we can use the IV and the key stream which we collected from this exchange and just encrypt this new challenge with the access point sent and send it back to it and authenticate successfully. Beautiful. Now you may ask the question, then how do we go ahead and take both of this data, which if you notice is there in these two discrete packets, which is the authentication challenge text as well as the authentication challenge response, and actually XOR it and get the key stream. Now this is where AeroDump does a beautiful job for us. If you notice, there is already a little file created here called demo-01 blah blah blah, which is nothing but the BSSID of the access point .XOR. So actually AeroDump has been nice enough to do the entire XORing for the shared key authentication, and it has placed the key stream in this directory. Awesome. So we could just do a less on this file and it would warn you it's a binary file because it's just a key stream, which should of course have binary characters in it. And well, it's nothing much, just a set of bytes. So now comes in the second part. So what are we going to do? Well, now we have the key stream and also we have the initialization vector, which was used to encrypt the challenge. Now, any challenge which the AP sends us, we will be able to decrypt, right? And let's do a quick demo on that. Let me close Wireshark. And here is what we can do, is we can start creating a new file called fake auth, right? And let's start the sniffing. Right now, if you notice, nothing much happening here. Now what we will do is we will use air replay to do the fake authentication using the key stream which we just found over the air and have stored locally. So we'll use air replay, and I think most of you may already be aware that the option is fake auth, which we used in the last video. Some delay along with that. The interface is going to be mon0, and what we need to also give it is the SSID, which if you remember is E security tube, right? And finally, what we are also going to give it is the keystream file. This is the XOR file which AeroDump generated. So -y keystream file, -y, and then we have demo, and this is the XOR file. Perfect. Now AeroDump is still sniffing, and now my phone has been switched off. Actually, it's still on, but it's not sending any data, and that is the reason why we are not able to get the SKA here. But now we will do a fake authentication using the keystream and the IV. So here goes. Awesome. If you notice, the authentication and association have succeeded, and our friend AeroDump has also told us that it was able to figure out the key stream. Why? Because, well, we already have it, but it found it once again over the air, right? And this is where it's once again stored the same key stream, but we can quickly again open up Wireshark and look at what our alpha card had done. So we open up the fake auth.cap file in Wireshark, and what we are really interested in is wlan.addr equals give it the MAC address of the access point, and now what we are really interested in is does the authentication kind of packets. So here we go, right? And this time our alpha card was the one who is initiating the authentication request, and from that point on, well, the access point sends the challenge back, we send the encrypted challenge back, and finally the access point sends the success, right? Awesome. So our alpha card used the same initialization vector and the key stream it had derived from the authentic and authorized client and AP exchange to fake this authentication, right? And this is how it is possible to break shared key authentication. Right? So now here comes in the question, how all can we use the key stream and the initialization vector we just derived? Now the first use, as you already seen, is to break shared key authentication. There are other uses also which you may not find well documented or well used on most sites and forums on wireless. The next one, which is very interesting, is now we can encrypt small packets. Why? You'll notice when we study web that if we have the initialization vector and the key stream derived for that particular initialization vector and the real web key, then using that we can encrypt any packet. Of course, the maximum size is 128 bytes because that is the size of our key stream which we have retrieved. What this means is we can inject arbitrary packets up to a maximum size of 128 bytes without knowing the web key. Most important thing, we still don't know the web key, but we are still able to inject. Also, imagine what if we continuously now send deauthentication packets to the client AP pair, the authorized client AP. What would happen is the client would keep re-authenticating, and every time it would choose a new initialization vector and would actually generate a key stream to encrypt the challenge. Now, doing the reverse process, we will basically have a database of initialization vectors and the corresponding key stream, which we can collect over time and create a database. Now, this database can be used for decryption of packets which we find later on in the same network using the same initialization vector, right? So we'll take up this in more detail in the web encryption class. Don't worry if a couple of things were a little amiss here, but what I really want you to be the takeaway is shared key authentication is broken, and using AeroDump and Air Replay, it is trivial to break shared key authentication and impersonate an authorized client. Right, so we've already seen the demo, and that's all for this video. Hope you enjoyed it. I think now you're getting a feel for wireless LAN security, and now we are going towards even more challenging, I would say, examples. And now we'll just go ahead and keep raising the bar over and over again in all subsequent videos. Thank you. I really appreciate all the wonderful comments you've written. Please keep them coming. That is what keeps me going. I cannot stress that more. So thank you. Bye-bye. See you in the next video. Have fun.